Okay, so in this video, we're going to learn how to graph a system of linear inequalities. So now, great prerequisite skill to have for this lesson is to know how to graph a linear inequality. So if you're not familiar with how to do that, please see my video, Graphing Linear Inequalities. Okay, because it's the same process, except we just do it twice on a graph. All right, so remember, when you have less than or equal to or greater than or equal to, when you have that line underneath your inequality symbol, you're going to have a solid line, no line underneath, you're going to have a dashed line. All right. For our shading, if it is less than or equal to, we shade below the line. If it is greater than or equal to, we shade above the line. So same rules apply with a system of linear inequalities as with just graphing one inequality. So basically what we're going to do, we're going to graph, and shade. And the solutions to this system would be where the two shaded parts intersect. All right, so let's get started. So to graph this first one, y is less than or equal to negative 2x plus 8. I'm going to go up to 8 on my y-axis because that is my y-intercept. 1, 2, 3, 4, 5, 6, 7, 8, where my graph crosses the y-axis. Negative 2 is my slope. So I need a 1 underneath for my run. So negative 2 over 1. I'm going to go down 2. 1, 2, to the right 1. Down 2, to the right 1. All right. Keep doing that until I reach the end of my graph, just to be precise. All right. And since it is an equal to sign underneath, less than or equal to, it's going to be a solid line. Try to draw it as straight as possible. All right. So that means all the solutions on this line would be included for solutions for the inequality. All right. This is less than or equal to, so I'm going to shade below the line. Shading below. So we graph this first one. All right. So now let's graph the second one. I have negative 5 for my y-intercept, so I'm going to start here. 1, 2, 3, 4, 5. All right. And then 3 for my slope, so 3 over 1. Go up 3 over 1. Over 1. There we go. One more point, or a few more points on the left-hand side of my y-intercept. So I'm going to go down 3 and back 1. 1, 2, 3, back 1. 1, 2, 3. Off the graph, but that is okay. This is just greater than, so it doesn't have an equal to sign underneath, so it's going to be a dashed line, meaning the solutions or the points on this line will not be considered solutions. Right, and then this says y is greater than, so I want to shade above the line, and above the line would be over here. So my solutions are where we have the blue and the burgundy intersections right here. I wouldn't shade over here because I didn't shade for this graph on this side. So these would be my solutions, because my solutions would be where the graphs, their shading intersects. Okay, so I've taken this problem a step further by putting possible solutions and not solutions. So let's analyze this graph. So possible solutions are 0, 0, and negative 5, 0, because remember, the solutions are only where the shadings of the graphs intersect. So the ordered pair 0, 0 is right here. And the ordered pair negative 5, 0 is here. So those are possible solutions. It could be any solution that is in that shaded region. But not solutions or no solutions are 8, 0. So be here, no shading, but also 3, negative 3. We go over 1, 2, 3, down 1, 2, 3. So although it's shaded for my first graph, it's not where the graphs intersect. So that would not be a solution. All right. So now we've graphed this system of linear inequalities and found some possible solutions and some solutions that, well, they're not solutions. All right, so I have another system of linear inequalities. 4x plus 2y is greater than or equal to 10. 6x plus 3y is less than negative 9. I would like for you to try this on your own. So get some graph paper and try to graph this system of linear inequalities on your own. So go ahead and pause the video and try this one on your own. All right, so hopefully you paused the video and you remember that you needed to rewrite each one of these equations in slope-intercept form. And so for the first one, you have to subtract 4x from both sides and then divide 3 by 2. Negative 4 divided by 2 is negative 2x. 10 divided by 2 is 5. So I'm left with y is greater than or equal to 2x plus 5. Over here, I had to subtract 6x, then divide 3 by 3. Negative 6 divided by 3 is negative 2, and negative 9 divided by 3 is negative 3. All right, so the first thing we had to do is to rewrite the equations. All right, so now go ahead and graph it if you haven't graphed it yet. All right, so I've graphed both equations, so hopefully you got it correct. So over here, the y is less than negative 2x minus 3 is here, and then y is greater than or equal to negative 2x plus 5 is graphed here. And so what do we notice about these graphs? Because the solution to a system are where the graphs intersect or where their shadings intersect. We notice that their shadings do not intersect. And so the solution to this system is there are no solutions to this system of linear inequalities because they don't have any graphs or any ordered pairs in common. All right. So hopefully you got it correct. Thank you for learning with me.